Hello students, today we are going to discuss multiple access techniques for wireless communication. Multiple access techniques are useful to provide wireless communication services to many users over a wide area network using a fixed bandwidth simultaneously. That means we are using a fixed bandwidth and we are dividing the bandwidth in between the users in different ways. So there are mainly four types of multiple access techniques: FDMA, that is frequency division multiple access; TDMA, time division multiple access; CDMA, code division multiple access; and IDMA, that is the interleaved division multiple access. In FDMA, individual channel is allotted to individual user. As we see in this diagram, there are two channels which are allotted to different users, and the overall bandwidth, that is the overall channel bandwidth, is separated into two channels, channel number 1 and channel number 2. Each user is allocated a separate frequency band, and these are assigned according to requirement of users. During a call, both the user will share the same channel. That means overall frequency bandwidth is divided in terms of frequency here. Each user will be allotted a particular frequency or channel, and the two users which are talking to each other will be using the same channel. To understand this concept, we will consider GSM system, where a mobile user 1 utilizes resources of base station to communicate with another mobile user, that is user number 2. The transmission from mobile user to base station is known as uplink, and transmission from base station to mobile user is known as downlink. In GSM, large frequency band of 25 MHz is divided into smaller frequency bands 200 kHz, which are known as channels. As we can see in this diagram, here we have bandwidth starting from 890 MHz 890.1 MHz to 914.9 MHz, and there are overall 124 channels, and each channel is having bandwidth of 20 kHz, as we can see in the diagram for uplink FDM. And for downlink, we are using frequency band from 935 to 960 MHz. Here too we have channel 124 channels, and each channel is having 200 kHz bandwidth. For communication between users and base station, one dedicated frequency will be used for uplink and one for downlink. And in GSM, simultaneous transmission are possible, as we use in full duplex mode. Advantages of FDMA. As we have seen, each user is allocated a separate channel. So there are dedicated frequencies to different stations and separate bands for both uplink and downlink, and the station can transmit and receive continuously at their located frequencies. They don't have to wait for their chance, because they are having a particular frequency band allocated to them, so they can transmit it whenever they want to. And it is simple to implement. This type of multiple access technique is efficient when constant traffic is required with less number of population, and it reduces the cost, and inter-symbol interference is less in this case. Disadvantages of FDMA. As we discussed in advantages, a particular frequency is allotted to a particular user, but that is advantages up to the user is using that frequency. If user does not use that frequency will be wasted. Next is, in between of different channels, there are guard bands used to prevent interference, that is wasting the bandwidth. And it requires RF filter, that is the radio frequency filters, to avoid adjacent channel rejection. Adjacent channel means in the cellular communication system we have hexagonal cells. when one cell interfere with another cell, that is known as adjacent channel interference. So we need RF filters in FDMA to avoid this type of interference. So this will increase the cost of the system, and network and system planning is tough. Second is time division multiplexers. Now the question arises, why we go for time division multiplexers? In the FDMA, it was a limitation when the user is allocated a frequency, but the user is not using that frequency. No other user can use that frequency because that is allocated to some particular person. Other person is not allowed to use that frequency. So that means we are wasting bandwidth. As we know, bandwidth is limited and costly. So we can't let the bandwidth wasted. So to avoid the wastage of bandwidth, we used TDMA. What TDMA do? It splits radio spectrum into time slots and distributes the slot among multiple users as shown in figure. As we can see here, there are different slots, slot 1, 2, 3, 4. So here the overall channel bandwidth is divided in terms of time slots. Each user will use a different time slot for its transmission and reception. And this type of duplexing is known as TDD, that is time division duplexing. But transmission of all users data is not continuous, that because each user will be given a particular time slot only. And there is a guard bit between slots so that interference is minimized. But TDMA requires synchronization because the user shares the bandwidth in frequency domain. Synchronization means when the transmit, for example, there is transmitter 1 to transmitter 4 and there are receivers 1 to receiver 4, and each transmitter is means correlated to the receiver side. For example, transmitter 1 to transmitter 1, transmitter 2 to transmitter receiver 2, 3 to receiver 3, transmitter 4 to receiver 4. So each of the receiver and transmitter should know at what time they can transmit or receive. Because their time slot is fixed, they can't receive their data at another slots. So they must know their slots. So there should be synchronization between the transmitter as well as receiver. This was not in the case of FDMA, because in FDMA there was a dedicated channel. The users can use their channel whenever they want to. But in time division multiplexers, they are given a particular time slot only, so they can use the system for that particular time only, not in other times. Advantages: it separates user according to time, so it ensures that there is no interference from simultaneous transmissions. And TDMA can be used for data as well as voice communication. It provides extended battery life because it transmits only portion of time during conversation. Disadvantages: because the user has a predefined time slot, when moving from one cell site to another, if the time slot in this cell are full already, then the user might get disconnected. And it requires network and spectrum planning. Multipath interference exists there that affects the call quality, and switching from one base station to another results in dropped calls. Next is CDMA, that is a code division multiplexers. As the name is code, so in this case a user is assigned a unique code for all speech signals. So here we can see in this diagram we have different channels, channel 1 to channel n, and each channel is having a different code. In CDMA, the same bandwidth is occupied by all the users. However, they are all assigned separate code which differentiate them from one another. So here we can see in this diagram, it uses a spread spectrum technique in which a spreading signal which is uncorrelated to the signal and has a large bandwidth is used to spread the narrow band message signal. So user 1 is having code 1, similarly different user will having different codes in this case, that are known as PN codes, that is the pseudo noise codes. To generate pseudo-noise codes, we use XOR operator, in which we go on inserting the bits. And for example, we use a 4-bit pattern in this one. A 15-bit code is generated from this one. So that is totally different from the 4-bit code that we have inserted. So no one can encrypt our data, because the 4-bit code that was the original message is totally different from encoded 15-bit code. So that is more secured. Advantages. Each user uses a different code to modulate the signal. And the best performance in this will occur when there is a good separation between the signal of the desired user and signal of other users. And it is not easily decodable, as we have discussed, because each user will have a different code, and that code is different from the original message sequence also. So this increases the security. CDMA does not require any synchronization, and it is impossible for hackers to decipher the code sent. CDMA system performance degrades with the increase in number of users. As the number of users increase, its performance degrades. And it suffers a near-far problem. This is an important problem in CDMA. This problem arises because handsets may be anywhere within the particular cell boundaries. Means we have hexagonal cell structure. In that cell structure, the user may be anywhere. Some handsets will be close to the base station. Base station is base transceiver, the receiver transmitter, the antenna which is transmitter as well as receiver. So some handsets will be close to the base station, whereas others will be much farther away. So this is known as near far problem, means ki the distance from the base station to the user, it may vary. While using CDMA, code length had to be carefully selected, because this can induce delay. When the number of users increase, overall quality of services decreases, because when as we discussed, it uses more bandwidth. When the number of users will increase, that means it will require more bandwidth, so system complexity will increase. Higher cost due to greater equipment. Next is IDMA, that is a interleaver division multiple access. Here the users are distinguished by user-specific interleavers, orthogonal in nature. In CDMA, it uses much more bandwidth. Obviously, signal is secured, but the problem is it is using more bandwidth. So bandwidth is limited and costly. So we can't use bandwidth as a requirement. We have to see the limitations of bandwidth also, ki how much bandwidth we are provided and how much of that we can use. So in IDMA, here we use user-specific interleaver that use somewhat less bandwidth than CDMA. It is a technique by which traffic bandwidth in a shared telecommunication medium can be allocated on demand and fairly between different users of that bandwidth. In this type of system, we give the bandwidth according to the traffic demand, and separation of users is achieved by user-specific interleavers. So here every two interleavers related to the specific users out of set of interleavers collide up to the minimum extent. This is a figure that is describing the difference between CDMA and IDMA. In the upper diagram, we have CDMA. First of all, we have data input, whatever data we want to transmit. Then FEC is the forward error correction. That means that we are using some bits so that we can correct or detect the errors in the data we are transmitting. Then we are encoding the signal to some form, and then we are spreading the signal. So then there will be signal generated, that is XM. But in IDMA, we use the same process. We use forward error correction to detect or correct errors. Then we spread the signal. We have spreaded the signal commonly. Then we will code the signal and then we will transmit. In conventional CDMA, the spreader is user specific, but in IDMA, the interleaver is user specific. This is IDMA model. Here we are using K simultaneous user, which are using a single channel path, as we have seen in the diagram. Multiple access, multipath channel. Multiple access technique भी use कर रहे हैं and multipath channel. ठीक है. Here data sequence of user K is encoded into chips. Chips are interleaved and the value is given by Rj is equal to sigma, K is equal to 1 to capital K, Hx, Kx, Xk, Hk, Xk plus Nj. J varies from 1 to J. Here Hk is channel coefficient and it is already known by the receiver, and Xk is the transmitted bit sequence. The principle of iterative multi-user detection is used in this technique. Here in this diagram, we first of all are encoding the signal, as we have seen in the basic diagram. Encoding the signal, then spreading the signal, then interleaver is used according to the user requirement. Then signal combiner, because we are having users from user 1 to user K. So this is the coder and spreader block. Then through the channel, we will transmit it to receiver end. Now at the receiver side, we have ESEB, that is the elementary signal estimator block. That will receive our signal and it partially resolves MAI, that is the multiple access interference, without considering FEC coding. Then output of ESEB is passed through SDEC, that is a signal decoder. So that will decode the signal that we have transmitted from the upper side of the block diagram to encoded signal will be decoded now, and then we will get the data. Features of IDMA. Here the receiver cost is low and complexity is independent of the user number.